So, in these starter questions that you've been asked to do today, there were essential fraction skills that are required for the next part of our work in fractions, which is looking at addition and subtraction of fractions. So these are some of the things I need you to be able to do. Hopefully, as I'm going through these, you're checking your own answers and showing that you actually do understand all these skills that I need you to be aware of. So the first one here, you're looking at equivalent fractions, and in order to find your equivalent fractions, one of the processes that we use is multiplying top and bottom numbers of a fraction to change it into an equivalent fraction. So here clearly, if we've had to go from 9 into 36, it means that we had to multiply top and bottom by 4, which would mean that we were looking for the top number in here to be 20. So hopefully you've got that correct. If we look at the second one, we'll see it's the top number that we've got a pair of. So if you're trying to think about your times tables with that, 4 times what makes 12? Hopefully you can see that it would be 3, which would mean we would also times the bottom by 3, which would therefore mean that I would be looking for 3 times 25, which would be 75. So 4 over 25 is equal to 12 over 75. So that is one way to find equivalent fractions, is to do this multiplying top and bottom, numerator and denominator of your fraction by the same number. Another method for finding equivalent fractions is to do this simplifying process, where you are looking for common factors. What number divides into 12 and also into 20? The easiest way to do this is to try and find the highest common factor. So for this one, the biggest number that divides into 12 and into 20 would be to divide by 4 with your top number and your bottom number, and that would therefore produce our equivalent fraction of 3 over 5. And that's as simple as you can make it. If you didn't spot that you could divide by 4 and you went for the fact that 12 and 20 are both in the 2 times table and you divided by 2, top and bottom, you would get the answer of the 6 over 10, top and bottom with this. So we would have 6 on the top, 10 on the bottom. But what you then notice, or what you should then be seeing, is that, well, I could still divide by 2 again, because I've not made it as simple as I can. The aim is to get down to a point where there are no other common factors. You can't go any further. So if we divided by 2 again, we would end up with 3 over 5, and there's no other factors, nothing else that we can divide into those to make it any simpler. So you could go either to that, but 3/5 would be the simplified, the most simple fraction we would be looking for there. So with the second one, 20 over 42, I would be looking for you to spot that you could divide top and bottom there by 7, and that would give us 4 on the top, and 7 into 42 would be 6. Alternatively, I'm then looking for you to notice that we can still divide by 2 again, and dividing by 2 again would get us down to final answer of 2 over 3. We could, of course, have come or have spotted maybe that 14 is the highest common factor there, but I'm not expecting you necessarily to have noticed that. But like we said before, it might be that you divide by 2 top and bottom. If you did that, dividing by 2 top and bottom, you would get 14 and you get 21, and it might be that you would then notice that you could divide by 7, and dividing by 7 would therefore lead you to the final answer of 2 over 3. So that's how we can simplify fractions. So we can find equivalent fractions by, like question 1, multiplying up the way, or we can find them by simplifying, where we're dividing. And when we're trying to do that, we want to get it down to being as simple as possible. So that's one of the skills I need you to be able to do. Now, something else that we will use is this terminology is the lowest common multiple. Multiples are all about multiplying, your times tables. So if you're comparing two numbers and you're trying to find the lowest common multiple, what you're actually looking for is what's the first number that's in both those times tables. Now, my advice is always, if you're looking at two numbers like that, go with the bigger one first. So in this case, I've written down the 5 times table, and you might only need to write that down until you spot the first number that is in the 5 times table that is also in the 3 times table. So you'll see I've listed both times tables there. You can do this in your head, but the first number that's in both, or is common to both of those, is 15. So the lowest common multiple of 3 and 5 is 15. So being able to be familiar with that terminology, LCM is short for lowest common multiple, and you're thinking about your multiple times tables, this is a skill that will be required for adding and subtracting fractions. So it's quite important that you can work with this. So for another one, if we're finding the lowest common multiple of 2 and 8, so let's write in there that we're doing LCM. Right, so lowest common multiple of 2 and 8, and that is equal to, if you're looking through your times tables, I've written the 8 times table down there, and then I've written the 2 times table, but you will find that actually it's the very first number. So I didn't necessarily need to write all those out, and again, right, it's quite possible that you can think through that and put in your head the first number that's in the 2 times table and in the 8 times table is the number 8. Whereas if we're looking at the 6 times table and the 8 times table, and again I've written the 8 times table down first, and then I've got the 6 times table underneath that, and the first number there that's in common to both times tables is the 24. So the lowest common multiple of 6 and 8 is in fact 24. So as I say, that's a skill we'll be using. Now, we used this skill last week when we were looking at how to compare fractions. So if you're trying to work out which of these was larger and we were having to change our fractions into equivalent fractions, this is when we made use of this lowest common multiple. So lowest common multiple of 4 and 9. You look through your 9 times table, you look through your 4 times table, and the first number that's in both times tables is the 36. So what you'd be doing to compare these two fractions is you would be changing them both into 36, and hopefully you know that's times them by 4. Times them by 4 means that you'd get 28 on the top there. This one, on the other hand, is times them by 9, top and bottom, and that would get you 27 there. So once you've got that, you were asked for which one was the bigger fraction, which is larger, and you can see that 7/9 is bigger than 3/4. But you can only see that once you've compared them with the same denominator in the equivalent form. Now, the last type of skill that we've met, the last fraction skill that you've met, is the idea of working with mixed numbers or improper fraction, which is what 9/5 is. It's a top-heavy fraction, and the method for changing that into a mixed number, you take the bottom number and you are dividing into the top number. So you do 5 into 9, that goes in one complete time, so that means you can make one whole and you are left with 4. That's your remainder. So what that means for you is that you can write this as 1 whole, and you're going to have 4 of these fifths left over. The bottom number will still be the same. So 9 fifths is the same as 1 4/5. For 26 sevenths, you would do 7 into 26. So we would end up with 7 into 26. 7 goes into 26 3 times, and we are then left with 3 sevens are 21. You're left with 5 left over. That means that you can then write this as 3 5/7. That's your fraction. So they're just equivalent forms of the same thing as each other. So the last bit, changing to an improper fraction. The method that you use to get that from this mixed number back into just all about fifths would be you take your whole number, which in this case is 3, you times it by the denominator, which is 5, and you add on the numerator, which is 2. That gives us 17. That tells you how many of these fifths you're going to have. So that's where the 17 on the top of that comes from. So try and remember that whole number, whatever the whole number is, you times the denominator, right? So you go that way, times the bottom number, and then you go up to the top and add on what's up there. For a whole number, any whole number can be written as a top-heavy fraction over 1. So that is always a rule that you should remember. So not just 7, you could write 8 as 8 over 1, 10 as 10 over 1, and so on. So those skills that we've just gone through are essential. It's important that you've been able to grasp them, because they will be useful for our work on adding and subtracting fractions.